Picture this, a typical day on the streets of an animated city, and suddenly chaos ensues. A rogue shoelace has declared independence. What was once a humble piece of woven fabric, diligently holding together a shoe, is now an unruly whipping flag of rebellion. It's a sight that's both amusing and oddly relatable. Haven't we all grappled with those pesky shoelaces that just refuse to stay tied? The shoelaces escapade is a dance of freedom, a symphony of twists and turns. It's a spectacle that turns heads, halts traffic, and causes quite a commotion. But as the saying goes, every rebellion meets its match. And in this case, it's not a superhero with a cape or a magic spell, but someone who understands the subtle art of knots. The Knot Whisperer. The Knot Whisperer is a master of the intricate, the twisted, and the knotted. With a flair for the dramatic and a deep understanding of knot theory, they're the only one who can tame this wild strand. But who is this Knot Whisperer, you ask? And what exactly is knot theory? Well, that's a tale as tangled as the knots they unravel. Knot theory, in its simplest form, is the study of mathematical knots. It's all about understanding how things are tied, twisted, and shaped. From the DNA in our bodies to the knots that hold bridges together, knot theory is the hidden language of our world. And the Knot Whisperer? They're the translator, the one who can read, speak, and manipulate this language with ease. So as our shoelace continues its wild dance of freedom, fear not. The Knot Whisperer is here to restore order, and in the process, they'll take us on a journey into the twisted, tangled, and utterly fascinating world of knots. Who will tame this wild strand? Enter the Knot Whisperer. With a swift, confident gesture, our hero, the Knot Whisperer, steps in. Suddenly, the chaos of the city fades, replaced by the calm, commanding presence of this intriguing figure. The Knot Whisperer isn't your average hero. Instead of a cape or a mask, they wield a knowledge as vast as the universe itself, the knowledge of knots. Now you might be thinking, knots? Really? Are we talking about the kind you tie in your shoelaces? Well, yes, and so much more. Knots are everywhere, hidden in plain sight. They're in the DNA that makes up every cell in our bodies, in the cables that hold up mighty bridges, even in the fabric of the universe itself. And our Knot Whisperer, with their gravity-defying purple hair and stylish gloves, is a master of them all. But what does it mean to be a Knot Whisperer? Well, it's not just about tying and untying. It's about understanding the intricate language of loops and twists, the delicate dance of intertwining threads. It's about seeing the connections that others miss, the hidden patterns that bind our world together. Our Knot Whisperer is a scientist, a mathematician, an artist. They see the beauty in a well-tied knot, the elegance in a perfectly balanced loop. They understand the power of a knot, the strength it can provide, the problems it can solve. They know that every knot has a purpose, a reason for being, and they're here to share that knowledge with us. So, as we step into the world of the Knot Whisperer, we're not just exploring the realm of knots. We're delving into a universe of connections, of patterns, of intricate beauty. We're discovering the hidden language of our world, the ties that bind us all together. Buckle up as we dive into the swirling, vibrant realm of the Knotverse. From the tiniest knot in a shoelace to the vast, cosmic knots that weave through our universe, we're about to embark on a journey like no other. So get ready, because the Knot Whisperer is here to guide us, and the adventure is just beginning. Welcome to the Knotverse, a fantastical realm where knots rule supreme. Here, in this vast expanse of twists and turns, knots aren't just simple ties or tangles. They hold a far more profound significance, a language of their own that echoes across the universe. From the tiniest particles to the grandest cosmic structures, knots are the unsung heroes silently orchestrating the dance of existence. Consider the humble shoelace, an everyday knot we often overlook. It's a symphony of loops and twists, a marvel of engineering that keeps our shoes on our feet. It's a testament to the hidden complexity and beauty of knots, a small reminder of the intricate web that binds the universe together. But the influence of knots extends far beyond our shoelaces. It permeates every aspect of our lives and the world around us. The DNA that courses through our veins, the blueprint of life itself, is a complex knot, a twisted ladder of genetic information. Knots are the architects of life, silently shaping our existence from the shadows. Then there's the world of architecture and engineering. where knots play an equally critical role. The knots that hold bridges together, that keep our ships afloat, that secure our planes in the sky. Each knot a testament to human ingenuity, to our ability to harness the power of the Knotverse to build and create. And that's just the tip of the iceberg. The Knotverse is vast, its depths unexplored, its secrets yet to be unraveled. Every day, we're finding new ways in which knots shape our world, from the proteins that power our bodies to the cosmic strings that stitch the universe together. Knots are more than just ties or tangles. They're the building blocks of everything, the threads that weave the tapestry of existence. The Knotverse is a testament to their power, a tribute to their silent, unseen influence. From the DNA in our bodies to the knots that hold bridges together, knot theory helps us understand how things are tied, twisted, and shaped. Knots are more than just tangles. They're the building blocks of everything. Let's dive into some real-world examples of where these fascinating twists and turns come into play. First up, we have the very essence of life itself, DNA. DNA is a molecule that carries most of the genetic instructions used in the growth, development, functioning, and reproduction of all known living organisms. But did you know that the structure of DNA is essentially a pair of twisted strands, a double helix? Yes, indeed. It's the knots and twists in the DNA that give it its iconic shape and function. It's like a microscopic dance of life, with every twist and turn choreographed by the laws of nature. Moving on from the micro to the macro, let's talk about bridges. Have you ever wondered how a suspension bridge with its long, swooping cables stays upright? Well, it's all about the knots. The cables are twisted and knotted together in such a way that they distribute the weight of the bridge and its load evenly across the supporting towers. This ingenious use of knot theory ensures the bridge's stability and longevity. And here's a fun fact for you. The world's largest knot is not something you can tie with a piece of rope. It's a network of highways and railway lines. Known as the Magic Roundabout in Swindon, England, this traffic knot consists of 5 mini roundabouts arranged in a circle. It's a fantastic real-world example of knot theory in action, managing the flow of traffic in an efficient and organized way. But it's not all about the big and the small, the organic and the inorganic. Knots are everywhere, from the ties we wear to the cables that power our gadgets, from the webs spun by spiders to the patterns woven into our clothes. But where did this fascination with knots begin? Well, that's a tale for another time. Until then, keep exploring, keep questioning, and remember, knots are more than just tangles. They're the building blocks of everything. Time to meet an eccentric scientist from the past, the smoke ring sage. Picture this. It's the late 19th century, and our sage is puffing away at a contraption, producing smoke rings. He believed that these rings, these knots of smoke, were the key to unlocking the mysteries of the universe. This idea wasn't as whimsical as it might sound. At the time, scientists were grappling with the concept of the atom, trying to figure out what these tiny particles were made of. Some scientists, like our smoke ring sage, proposed that atoms were actually knots of ether, an invisible substance they believed filled all of space. The idea was creative, to say the least. They even developed an entire table of knots mirroring the periodic table of elements, each knot representing a different atom. Imagine that, a world made up of nothing but knots. However, as with many scientific theories, this one didn't quite stand the test of time. The ether theory was ultimately disproven, and with it, the idea of knot atoms went up in smoke. But don't discount our sage just yet. This wild idea sparked a fascination with knots that has endured to this day. The study of knots became a field in its own right, knot theory, a branch of mathematics. It's all about understanding the properties of knots, how they can be twisted and turned without being broken. This isn't just theoretical, it has practical applications in various fields, from understanding the structure of DNA to the physics of the universe. So, while the smoke ring sage didn't unlock the mysteries of the atom with his smoke ring knots, his creative thinking and curious spirit contributed to a whole new field of study. The history of knot theory is a testament to the twists and turns of scientific discovery itself. Turns out they were a bit knotty. Despite the laughs, knots play a crucial role in our understanding of the world. Believe it or not, but the science of knot theory actually unravels the secrets of materials and even the structures of proteins. In the realm of material science, knots are more than just tangles. They're the building blocks that hold things together, from the strings of a guitar to the cables of a suspension bridge. By understanding how knots work, we can create stronger, more resilient materials. Think of a spider's web, the epitome of strength and flexibility, all thanks to the intricate knots that make up its structure. Now, let's delve deeper, right down to the molecular level. Picture a protein not as a mere blob, but as an intricately folded structure. This folding isn't random, it's a precise process, and it's essential for the protein's function. Misfolded proteins? They're often the culprits behind diseases like Alzheimer's and Parkinson's. Enter knot theory. By treating proteins as complex knots, scientists can predict how they'll fold. They can spot potential misfolds before they happen, opening the door to new treatments and even cures. But the power of knots doesn't stop there. Knot theory also helps us understand the strange world of quantum physics. In this realm, particles can be entangled, behaving as if they're connected by an invisible knot. By studying these quantum knots, we're pushing the boundaries of what we know about the universe. So, while knots may seem like a simple curiosity, they're actually a powerful tool. They bridge the gap between the macroscopic world of materials and the microscopic world of proteins, helping us understand how things are tied, twisted, and shaped. And speaking of impressive knots, feast your eyes on this record-breaking knot. This isn't your everyday garden variety knot. No, this is the world's tightest knot. Imagine, if you will, over 190 atoms intricately tied together, loops upon loops, twists upon twists, forming an almost impenetrable mass. This isn't just a tangled mess, it's a marvel of scientific achievement. Now you might be asking yourself, why on earth would anyone want to create the world's tightest knot? Well, it turns out this isn't just about bragging rights. This knot, this tightly wound bundle of atoms, has significant implications for the world of science. It's a testament to the power of knot theory, a field that, though often overlooked, has a profound impact on our understanding of the world around us. You see, by creating the world's tightest knot, scientists are pushing the boundaries of what we thought was possible. They're exploring new ways to manipulate atoms, to tie them together in increasingly complex and intricate ways. This could lead to breakthroughs in materials science, where the strength and flexibility of materials could be dramatically improved by incorporating these super tight knots at a molecular level. But it's not just about material science. This record-breaking knot is a symbol of the limitless potential of knot theory. The same principles that allowed scientists to tie over 190 atoms together could be applied to untangling the mysteries of the universe, from the structure of DNA to the fabric of space-time itself. So the next time you find yourself struggling with a particularly stubborn shoelace or a tangled ball of yarn, take a moment to appreciate the humble knot. Whether it's the world's tightest knot, a simple shoelace knot, or anything in between, these tiny tangles are more than just nuisances. They're a testament to the complexity and beauty of the world around us. And now, back to our shoelace problem. With a deft hand, our knot whisperer shows us the power of a well-tied knot. Ever had a shoelace fall out of line? It's quite a nuisance, isn't it? But fear not, because the knot whisperer is here to introduce us to a simple yet powerful solution, the square knot. This knot is a classic, a humble hero that's often overlooked in our daily lives. The square knot, also known as the reef knot, is a binding knot that's been used for centuries. It's a simple knot, but don't let that fool you. It's reliable, it's strong, and it's incredibly versatile. You can use a square knot to tie your shoelaces, to secure a package, or even to tie a bandage in an emergency. How do you tie a square knot, you ask? Well, it's as easy as 1, 2, 3. First, take the right end of your lace and cross it over the left end, then tuck it under and pull it through. That's your half knot. Next, take the end that's now on the right, cross it over the one on the left, tuck it under and pull it through. And voila, you've got yourself a square knot. But what makes the square knot so perfect? It's in its balance. The square knot is a symmetrical knot. This means that the tension is evenly distributed across the knot, making it less likely to slip or come undone. Plus, it's easy to untie, which is always a bonus when you're in a hurry. So the next time your shoelace decides to rebel, remember the square knot. It's a small piece of wisdom from the world of knot theory that can help you in your daily life. The square knot is a testament to the fact that even the simplest of knots can hold great power. Remember, there's a perfect knot for every situation. As we return to our city, we see it in a new light. It's not just a bustling metropolis, but a testament to the hidden threads that intertwine, shaping our world. Knot theory, once the domain of knotty scientists, now illuminates our understanding of the universe in unexpected ways. Take a look around. The DNA that encodes the blueprint of life, the proteins that drive biological processes, the architectural marvels that defy gravity, even the humble shoelace, they're all bound by the principles of knot theory. It's as if everything we perceive is part of an elaborate cosmic macrame. But it's not just about tangible entities. Knot theory also permeates the abstract realms of mathematics and physics. It propels our understanding of quantum physics, where particles become entangled, a phenomenon akin to the most intricate of knots. In the realm of pure mathematics, knot theory gives rise to exotic, twisted shapes, challenging the limits of our imagination. Our digital world, too, is tied up in knots. Cryptography, the science of secure communication, employs knotty algorithms to keep our online transactions safe. Knots protect our secrets, knotting and unknotting in complex patterns that confound even the most determined cyber thieves. But the reach of knots extends beyond the physical and digital. They're woven into the fabric of our cultures and traditions, from the intricate Celtic knots symbolizing eternity, to the Chinese endless knot signifying longevity and wisdom, to the African love knot expressing affection and commitment. Knots carry a universal language of connection and continuity. As we unravel the mysteries of knot theory, we're also tying together disparate threads of knowledge. The study of knots is a testament to the interconnectedness of our universe, a reminder that we're all bound together, inextricably, in this grand tapestry of existence. Knot theory shows us that even the most unexpected things are linked by a hidden thread. Science, like a well-tied knot, can unravel the mysteries of our world. As our journey into the Knotverse comes to a close, let's recall the magic of knots. From the rebellious shoelace to the world's tightest knot, from the DNA helix to the knotted bridges, it's been a thrilling adventure. We've seen how knots are more than mere tangles. They are the building blocks of life and the universe. Knot theory has helped unravel mysteries, and it continues to shape our understanding of the world. Remember, whether it's shoelaces, DNA, or the fabric of the universe, we are all, in one way or another, knotty